I don't know if you can see me in the corner there. I'm sort of hidden by my big headset, but I wanted the better microphone, so I went with my air traffic controller's outfit today. Um, that's what Will calls it. It's like, okay, it's a gaming headset, dude. Come on, give me a break. But it's got the best sound. So I've given this presentation, or rather versions of it, for about the last 10 years. I started giving them, and I'll actually go to the next slide here. Just to, well, if I can click on the right stuff here. Maybe. There it is. Just gives myself a little bit of an introduction. So I'm Vice President of DFT Architects, and I work here at Leander. I was a state and federal surveyor, or rather inspector, for the Department of Aging and Disability Services, which is now back under Health and Human Services Commission. But that they license assisted living facilities, nursing, SCFMR, state supported living centers, you name it. And in about 2 years, I was an architect in the state office. And in 2 years, I did just about 100 inspections or more of long-term care facilities. And most of those were for brand new facilities. Some were for existing. The problem children is usually where I ended up getting sent. And we were inspecting for absolutely everything. Because if you're familiar with DADS or any of the long-term care, they don't inspect until the building is totally done, 100%, because they don't have the funds or any kind of funding mechanism to come in the middle of construction, which is what makes the most sense, but not when we can get in there. So we inspected everything from rated construction and plumbing and every system, fire alarm, fire sprinkler. If it had anything to do with code or anything to do with the licensing rules, we inspected it. And so we had anywhere from 2 to 6 inspectors from a day to a week. Solid. So these were incredibly long ones. It was sort of a trial by fire. It was like going back to school. Prior to that, I did mostly schools in Florida and some here in Texas, about 6 million square feet in 5 years, because that was right before the 2008 bust. And so I have a lot of experience both in healthcare facilities and schools, as well as commercial and a whole wide variety. I've done aviation and a whole bunch of other stuff. And so as part of being at the state, I did a lot of joint training seminars and such. So I gave training to both people in the industry as well as the surveyors themselves. And then even after I left the state, my previous boss would have me come out, and I did training for the people that were now inspecting my buildings. And I've also given seminars and presentations to national groups like the NFPA National Convention in Vegas, as well as a number of other things. And then I also have, I'm not your normal architect, neither is my partner. We have quite a bit of construction experience, both of us. I spent summers doing construction. I built my own house, and I do a lot of things on my own. We actually started a construction company about 3 years ago. So I'm actually president of TBA Healthcare Development, which is a small construction company, and we do primarily long-term care stuff. We do a lot of the dirty work nobody else wants to do. And a lot of it having to do with life safety code, rated barriers, fire stopping, you name it. So I have a wide range of, I know too little about too many things. So knowing that when I go into a lot of this stuff, I've tried to make this presentation a little bit different from what I've done before, in that I don't cite the code sections. I don't get into which sections of the code these things come from. I just talk about why. Why do we got to do it? And what do we got to do it? Where do we have to do it? Etc. So, because people that are out in the field and getting it done don't give a crap about which section of the code says you got to do it. You just want to know, what do I got to do? Tell me how to do it, and I'll get it done. So this presentation is modified from, it's definitely more for the guys and gals in the field that are getting it done. So, and then I don't have too many cartoons in this one because you guys have other things to do. But death by PowerPoint is a problem. This is I do have a lot of slides, but a lot of them are very simple because I have a lot of pictures. So this actually was based on an AIA like one that you could actually get credit for as an architect. So some of it I've left in there, like the learning objectives. Basically, what this whole presentation is, I want to teach the difference between the required locations for fire barriers, smoke barriers, fire walls, fire partitions, and smoke tight partitions, and what the heck each of those different things are. Because it's incredibly important that actually when you're referring to the different kinds of barriers or partitions within a facility, and we have in the Chandler Estates project several of these, and they all have different requirements. They all have different requirements for how they're built, and in some ways, how they're fire stopped. For the most part, when we get into fire stopping, it's the same regardless of what kind of barrier it is. We're also going to talk about what fire blocking is. Because when we first, this whole thing came up from some of the submittals that I originally started to get on fire stopping, and some of those were fire blocking materials, or fire blocking foam, etc. So I wanted to make it extremely clear what the difference between fire blocking and fire stopping is and where they're used, because only portion of this project, or only portions of this project have fire blocking in them, and others do not in any way, shape, or form. And there's only certain things you can use for fire blocking in commercial construction. Others you can use in residential. I'll get into that. Then I'll talk about what through penetrations and membrane penetrations are, as well as give you lots and lots of examples, because the pictures, say 1,000 words, even though I might talk too much. And then talk about the different components of a fire stopping system and understanding what a fire stopping system is in general. So I'm used to hitting enter. There you go. So fire resistive construction, why? Well, the whole point of having fire resistive construction, and mind you, I don't call it fire retardant, fireproof, fire rated. The code's term is fire resistive. Almost everything burns. Concrete spalls and cracks after a while in a fire. Even and stone actually is terrible. Stone actually cracks like crazy. Even non-combustible items burn. They don't necessarily burn, but they're affected by fire. So we talk about all this is actually referred to as fire resistive, because the whole point of this is just about time. And the whole point is to give occupants the time and a path to safely evacuate. And I'll get back into those. Those terms are really important. It's time, the way to get out, and safely get out. Those three elements are very, very important to the entire thing when it comes to fire resistive construction and life safety systems in general in the building. The whole point is to get people out safely. We don't care about the building too much and when it comes to life safety. Now, the building code has additional things like windstorm and other things, so that the building can be a little more resilient and maybe doesn't fall down from the hurricane, or can be repaired and isn't totaled and wiped out every time you have a fire or an event. So building code does go into it farther, but the first and foremost, it's the safety of the people within it and how quickly can you get them away from the danger. And sometimes the danger is literally moved to the other half of the building, especially in healthcare. So first I'm going to get into an example. I'm going to get into why we do this and what goes wrong when we don't. And some of you may or may not be familiar with this. And so in school, they love talking to us about disasters because they're the easiest way to describe when things go wrong, and usually teach us some lessons. So the MGM, excuse me, the MGM Grand Casino was 26-story. This is now Bally's, I believe, after it was renovated. It was opened in 1973 as the premier casino on the Las Vegas Strip. Had about 2,000 rooms, slightly over that, and about the whole casino, including the casino floor, was about 2 million square feet. And it was quite the thing for its time. So the fire was on November 21st, 1980, and the fire started from an electrical ground fault within a wall of the deli restaurant. This was done on the casino floor, and it was something about equipment rubbing up against the wall because it wasn't attached correctly. I haven't heard all the exact specifics, but nobody was in the restaurant at the time. The building was originally designed to be open 24 hours a day. The whole building, all the casino, everything, and every restaurant. So they fought the fire marshals when they first created this building, and they're like crazy. And MGM balked at the idea of putting in sprinklers across the entire thing. It was a $105 million casino, and they decided not to spend the 192 grand to put in sprinklers across the whole thing. And so because they figured it's going to be open 24 hours, they can put everything out. Well, then they decided to not keep the deli restaurant open 24 hours. So at 7:05 a.m. it was first noticed, and the fire department was notified at 7:17 a.m. Why the difference? They had no automatic fire alarms either. No smoke detectors. The manual fire alarm system doesn't work, and there's an automatic delay when they even did a manual pull to give time to decide whether or not to let people know. And so the fire department was notified at 7:17. They got on site within 2 minutes. 6 minutes after the fire was initially found, it had engulfed the entire 450,000 square foot first story of the casino, which is the entire casino. It was burning at a rate from one side to the other at 15 to 19 feet per second is how fast it was moving. It was literally a fireball going from one end to the other. The entire casino was covered in combustible furnishings. The interior finishes were foam, plastic molding, everything that looked like it was crystal and everything was all plastic. And so all the foam padding, all these moldings and all that kind of stuff was just burned at an incredibly hot rate and created an intense amount of smoke. And so it was a big wide open. You've seen, if anybody's ever been to Vegas or any casino, they're huge and they're wide open. And that fire just exploded throughout that entire thing. And obviously it created a significant amount of smoke. There were about 5,000 people in the hotel at the time of the fire. Excuse me. The fire killed 85 people and sent 650 to the hospital. Of those 85 fatalities, only 4 died as a result of burns. 1 jumped from the building, and 80 died of smoke inhalation and carbon monoxide. 18 of those 85 victims were on the first floor. That's with the casino. The other 67 were located on floors 16 through 26. So 67 people that died from smoke inhalation and carbon monoxide poisoning were 15 floors away from the fire, nowhere near the flames. The fire was contained by the firefighters it never exceeded the second floor, and it never went past it, but yet most of the people died on the upper floors. And so this is just one of those examples of how a lack of attention to systems, and this is both active and passive systems, can lead to serious consequences. And so what went wrong? They had no sprinklers, and so much of the building, some portions of the building did, other portions didn't. No automatic fire alarm, highly combustible toxic finishes and furnishings. The dampers did not work in the HVAC system, and it did not shut off. There were no requirements to have smoke, duct detectors that would automatically shut off the unit when detecting smoke. They had no requirement when the fire alarm went off at all to shut the units off. And the dampers that actually were installed didn't work. And so the HVAC system literally pumped smoke throughout the building. But it also pumped it in, what happened is it traveled up the towers. It traveled right up the chimney, like a chimney, right up through the staircases, and it went through all the cracks and all the expansion joints and all the stuff that was never fire stopped. It wasn't required to be. So every crack and every hole, all the way from the second floor to the 26th floor, was wide open, and the smoke just billowed from the bottom to the top. And in fact, when people tried to escape into the stairs, the doors locked behind them. You could only get out of the top and the bottom of the 26th story stair, and the stairs were filled with smoke because they actually had cut holes in the stair for an addition they were doing. And there was no fire stopping, no nothing, and the smoke and the gases just filled it. So anybody that went into the stairs died there. And so when I get into fire stopping, I get into fire resistive construction. I'm talking about the passive systems. I'm not talking about fire alarm and fire sprinkler as part of this presentation, but I get it all the time when I am very super picky about fire stopping. Because it's a passive system. It's there to protect everything protect the people when every other system goes wrong. When the fire alarm doesn't work, when the sprinklers don't work. And I always get the question, well, why do we have to do this? The building's sprinklered. Assume the sprinklers don't work. I inspected too many buildings where the sprinklers didn't work. I went into assisted living facilities that had supposedly just had their fire and sprinkler inspections, and then I went out to test it, and the test where you test it, it was shoved, it had pieces of metal shoved in it, which means there was no way they had tested it. Or then I went out and tested others, and the pressure was a quarter of what it needed to be because the city had shut one of the main valves off and had told anybody, but nobody had bothered checking the system. So you have to assume everything else is going to go wrong. So the passive systems, i.e. the fire resistive construction, is really the last resort, and it's the last protection for so many people. And this particular fire, as well as several others around that time frame in the 70s and 80s, led to substantially increased requirements for fire stopping. So so enough of the depressing. Fire resistive construction, there's two reasons that we have fire resistive assemblies. One is construction ratings, is to maintain the building's integrity. And what's the whole point of providing, what's the whole point of keeping the building up? Give people time to get out. It doesn't matter how clear the exits are, or how well the fire alarm works, or how well the sprinkler systems work. If the building falls down on you in 15 minutes, and you can't get out. And it's pretty straightforward. The bigger the building and the taller the building, the longer it takes to get out of it. Really straightforward. So when you have a one-story building and there's no stairs, everybody can get out really fast. And so you can make a much bigger building with a lot more people in it and not have to provide the fire resistance because you can go right out the doors and get out. But once you start going multi-story, or you have occupants such as a nursing home residence or hospital that can't get themselves out, you need more time. And so building constructions, so you'll hear construction rating of like this building's 1 hour rated or this building's 2 hour rated. That is a classification of the protection for the structural members of the building. It's not a matter of keeping fire from one side or the other. It's a matter of just keeping the building from falling down. That's another subject. It's directly related to what we're going to talk about. But in Chandler Estates, for example, none of the buildings are considered, I would consider rated. They're actually a type 5 000 on our type 5B under the building code, which means it's wood. There's obviously building 3, building 1, they're wood, and there's no fire resistive requirements for the structural components of the building, i.e. bearing walls, columns, slabs, roofs, etc. The next part is the other reason we do fire resistive assemblies is separation. Well, separation is so you can protect yourself from the fire and give you a safe path to escape. So again, as I mentioned in the beginning, the whole point of life safety is to give everybody enough time to safely escape the building. And so it's these two reasons we do fire resistive. That's what gives us the time and the safe path to get out. And it's not just the safe path for fire, it's smoke. The smoke and the carbon monoxide and other noxious gases that are created during combustion are, as you saw from the fire at the MGM Grand, are substantially more dangerous than the fire itself. More people are killed by smoke and the hot gases in a fire than by the fire itself. And smoke and hot gases can get through every pinhole in the building that they can find. Water won't go through as fast as the gases and smoke will. It's amazing how tiny of a hole will let through so much smoke and so much gas. Why? Because it's high pressure to low pressure. And if you know anything about the basics of pressure, you have a super hot fire on one side of a wall and you have it's cold on the other, and you have smoke and hot gases. If there's any hole between them, it'll escape that high pressure area as fast as possible through the little hole. And so that's why we provide barriers, partitions, and say firewalls. They inhibit the passage of fire and smoke from one side to the other. So the whole point of all these barriers is literally to keep fire and smoke and stuff on the other side of the wall, or contain it within, an area. There again, to give us the safe passage out. So there's a multiple multitude of different definitions or different types. They have fire barriers, we have smoke barriers, firewalls, and smoke partitions. The different codes have different, call them different things. But the whole point of them, they all prevent fire, smoke, or both from passing from one side to the other. I am going to give you the definitions real quick, but it's important because, like, if you look at Chandler alone, we have fire partitions, we have fire barriers, and we have firewall. And all three of them have different requirements. How the frame is different, how the gyp board is continuous or non-continuous, whether they're structural or not, and where they stop and where they start. So a fire partition is basically, it's a wall. It's non-structural, i.e., it doesn't have to be bearing. It could be, but in this case, the whole purpose of it being a fire partition is just to keep fire from one side to the other. And you notice it doesn't say smoke. So a fire partition is actually, the entire intent of a fire partition is just to keep fire from one side to the other. Now, when we start talking about fire stopping, there's no difference in the way we protect the wall. Mechanically, a fire partition would not have a smoke damper in it. If you had duct shrunk going through it that required dampers, a fire partition, because it doesn't talk about smoke, you would not have to have a smoke damper if it was going through a fire partition. A smoke partition is the opposite. It doesn't care about it's not concerned about keeping fire on one side or the other. It's about keeping the smoke. So that's sort of it's a cold wall. The whole point, and so you can use different materials to actually seal a smoke partition. In fact, you can just use latex caulk. But smoke partitions have no fire rating. They're just intended to limit the transfer of smoke. Then you have a fire barrier. Fire barriers are the most common thing you're going to see in almost any building that has fire resistive construction. And it literally is, it's a continuous membrane or membranes, i.e., gypboard on both sides of a wall, etc., where that particular assembly has been tested, so it has a specified fire resistance, i.e., it'll last for an hour, it'll last for 2 hours, etc., and it limits the spread of fire and restricts the movement of smoke. So the whole point of a fire barrier is actually to do both. It is to keep both the fire and the smoke on one side or the other. A smoke barrier is much like a fire barrier. A smoke barrier by definition doesn't worry about fire, but a smoke barrier is a continuous barrier that goes all the way from one exterior wall to the other exterior wall, goes from the slab all the way to the underside of the roof deck, and nothing interrupts it, including the ceiling framing, the ceiling gypsum board, nothing. The gyp board goes all the way through. In healthcare facilities, smoke barriers are required in healthcare facilities on every floor to separate the building into smoke compartments, i.e., you can stay in one side you can move to the other side of the building to get away from the fire, and that gives the staff and such more time to get people out. Ironically, in healthcare, all the smoke barriers required to be in healthcare facilities have to have a 1 hour rating, which makes them actually a fire/smoke barrier. They're actually both. In Chandler, we have fire barriers and we have fire partitions. We don't have any smoke barriers in the Chandler Estates project. And then the last definition is a firewall. I hear it in the field, and this, not just people in construction, but designers and architecture worse, calling everything a firewall. A firewall, by definition, is extremely specific. A firewall is structurally independent, i.e., one side of the structure on one side of the wall can fall down in a fire, totally collapse. And because of the way the firewall is required to be built, the other side does not fall down. And so firewalls are, they're only in the building code. They're not in NFPA 101, the life safety code. But firewalls are used to separate areas. Like if a building is too big, you can break it into multiple buildings. Firewalls are used to separate types of construction. So if you have a non-combustible building next to a combustible building, then you have to have a firewall to separate the two types of construction. We have a firewall, but that separates building 2 and building 3 in Chandler. And it is called a firewall for that exact reason, because we have type 2000 construction, or type 2B in the building code. It is non-combustible, unrated, and then on the other side we have combustible and unrated. But so the two totally different types of construction, and that firewall is actually, it's a double wall. In our case at Chandler, it's a double wall. So one half can fall down, basically. Let's say if building 3 burns to the ground, building 2 won't. That's the idea behind it. So it's really important. So when I'm out in the field and I'm even talking with other people and I hear them refer to something as a firewall, I think of firewall, and that totally changes the conversation depending on what we're talking about. I'd rather people just call everything a fire barrier and by mistake than call things a firewall, because when you talk with code officials or inspectors that know what they're looking at, or actually anybody that knows what they're talking about, and you call something a firewall, it's very specific. So I'm going to get off my soapbox about firewalls there. So orientation, smoke and fire partitions are only vertical. So partitions are they're just always walls when it comes to the definition. So we have all of our corridors are fire partitions. All of the tenant separation walls, so in between units, those are all fire partitions in Chandler, in all 3 buildings. Fire barriers can be horizontal or vertical. For the longest time, they were just vertical, just walls. But about 2015, 14 or 15, some companies actually started to get some barriers tested in the horizontal position. So you can actually, it's almost like building a wall horizontally using joists instead of treating them as studs. So they're bigger members, whether they're wood or metal. So they do have horizontal fire barriers. Smoke barriers are vertical or horizontal, because horizontal, as I spelled it there. They can be walls that go all the way from the deck, or excuse me, all the way from the slab to the deck, or they can be the floor ceiling assembly between floors. In fact, in a healthcare facility and a lot of other types of facilities, every floor is a smoke barrier, i.e., we don't want what happened at MGM to happen again. We want to separate every floor and keep every floor independent and smoke-wise. We want to keep the smoke from going up floor by floor. And then firewalls are vertical only, ever. You can't do a firewall horizontally. You can't stack types of construction, and that's really important. So if I have 2 stories of concrete, say for a parking garage, and I put a wood building on top of it, the entire building is considered combustible, because the actual Type 5 construction, which is what Building 3 and Building 1 are at Chandler, allows any material permitted by the code. Concrete could be concrete. You could have a totally non-combustible building and call it Type 5. It's the catch-all, but it's the only type of construction that allows wood or combustible construction. So when you're doing firewalls to separate types of construction, you can't separate them horizontally. You can't put a wood first story and then have a non-combustible second and third, because now the thing will collapse, because it's wood down below. Okay, rated assemblies are tested. They're tested in a furnace. They're tested in accordance with testing standards. Those standards are nothing but an instruction manual of how to test it. It goes in the furnace for this time. It's this size by this size. This is where you place the sensors. This is how fast you have to ramp up the heat, etc. So you see a lot of stuff in the literature for assemblies when it talks about these particular standards right here, NFPA 251, E119, and 263. Trust me, I won't test you on that any time. The whole point is those are the rule books for testing these assemblies. An assembly is not considered rated or having a fire resistive rating unless it has been tested, and it's only tested for what they wanted, i.e., a wall. Let's say a manufacturer says, I want to use my gypsum board, and I want you to test a wall that I want to last 1 hour. Well, the testing company does all their stuff, and they test it for 1 hour. If it doesn't fail the parameters, there you go. You get your 1 hour. They don't keep going, i.e., they don't just test it as long, let's see how long it lasts. No. If you want a 1 hour, they test it for an hour. If you're looking for a 2-hour assembly, they test it for 2 hours, and then the test says, how to shut it down. So, there's some things like concrete block that their assemblies can be as much as 4 hours. They might even last longer, but that's as long as the test went. And for me personally, as an architect and somebody who's liable putting my name on so many drawings, If I have nothing to back me up, i.e., if I don't have a tested assembly, especially when it comes to fire resistance, if I don't have something that's tested by a third party, I'm not going to use it, or I won't allow it to be used, because I'm not putting anybody's life on the line or myself in liability. I don't think anybody would do that to themselves if it doesn't have something to back it up. And the authorities having jurisdiction, AHJs aren't going to do it either. It used to be, years ago, they just sort of make the decisions on the fly on their own because they didn't have anything to back them up. Well, now they do, and they're going to require it. So, and I talk about assemblies all the time. In fact, people tease me constantly about using that term so much. Well, that's because everything that has to do with fire resistance has an assembly to it. It has an instruction manual of how to build the wall or how to do the fire stopping. And it's critical that everything is actually done per the instruction manual. So everything that has something to do with fire resistance in our buildings has an instruction manual on how to do it, how to build it, how to protect it, etc. These are just some of the testing agencies. You've heard UL a lot. The other ones are Intertech. ETL is actually a label under Intertech. Used to be Factory Mutual, but FM. And then ICC actually does a number of testing things as well. And then the Gypsum Association doesn't do any testing, but they actually have a whole bunch of assemblies for walls and ceilings and all that stuff that have been tested by other parties. And the International Building Code incorporates the entire Gypsum Association's fire resistive design manual into the code by reference. So anything in their manual, and you may hear me bring it up again in the field, depending on what I'm looking at, anything in that manual from the Gypsum Association is considered part of the building code. So okay, what are some fire resistive assemblies? Here's two very common ones. And one is a wall, and the other one is a floor ceiling assembly. And you'll notice I don't just say floor, because everything from the ceiling to the top of the next floor could be considered part of that assembly, depending on how it was tested. If you have nothing but a concrete slab, like we do in Building 2 in Chandler, the only portion of that floor, or that roof, or that floor ceiling assembly that's actually the rated portion is the concrete. And so none of the ceilings are actually part of that assembly. But there are assemblies, especially in light gauge construction, that the ceiling gypsum board is where the assembly starts, and the top of the concrete, above the deck at the floor level above is the other side of the assembly. And so you have to treat the entire thing as one assembly. And as the attics are trusses and are wood trusses, and especially in like Building 3, if it was rated, or Building 1, excuse me, if it was rated, that roof ceiling assembly would be from the gypsum board at the bottom to the shingles at the top. And you have to treat the entire thing as that assembly. Walls are easy. It's from one side of the wall to the other, for it to be rated. You can't do half of a rated wall assembly and have it be rated. The other part you have to remember about these is they're tested assuming both sides have fire or could have a fire on them. The exception being roof ceiling assemblies, where they don't expect to have a fire on the roof, on top of the roof. But walls and floor ceiling, you assume that there will be fire from both sides. So when we get into fire stopping, you have to assume that fire will come from both sides, and which is why things have to be fire stopped from both sides. So where are some of these required? Fire barriers are used to separate occupancies within a building. Fire walls are used, like we talked, to separate construction types to limit the size of buildings. Hazardous areas, storage rooms, laundry rooms, trash rooms, etc., like that, higher hazard than everything around it. Those are surrounded by fire barriers. Your stairs are considered fire barriers, so the barrier goes all the way from the bottom floor and it goes all the way up to the underside of the roof deck. And obviously we have that in Chandler for all two buildings have the stairs. And then shaft enclosures. Anytime there's an opening in the floor, that opening must be protected from the passage of smoke and fire. Exactly what MGM did not have. And so those are considered fire and smoke barriers, because you're also you have to keep smoke from going from one floor to the other. And then, like I said, in healthcare, for compartmentation, smoke barriers are used. Fire partitions are used very often to separate tenant spaces. Okay, so maintaining that separation. So you have these rated assemblies, and I'm not going to go into all the individual specifics about those assemblies themselves. The point of what we want to talk about today is protecting the integrity of those barriers, of those separation barriers or partitions. And there are two types of, or there are two sort of categories of protection we have to keep in mind: fire blocking and fire stopping. And they are totally, they're for the same reasons, to keep fire from progressing and moving. But they do it in totally different ways and in different locations. Fire blocking is required by the code, and what the point is to limit passage of fire and smoke within a concealed space. It doesn't matter whether it's fire resistive or not. Fire blocking is required in every single family home, and most single family homes have no fire barriers, smoke barriers, or even rated, floors or roofs, etc. Fire blocking is inside of the walls, inside the floors. It's inside the ceiling assemblies. Draft stopping is basically fire blocking for larger spaces, i.e. attics. For attics that are not fully sprinklered, i.e. they don't have an NFPA 13 system, they might have an NFPA 13R or D, then you have to keep fire from going across the entire attic quickly by providing draft stopping. And I'm not going to get into the specifics of draft stopping, but it basically is the same thing as fire blocking. The whole point of this is fire blocking is inside of those walls. It's inside the assemblies, and it is only in combustible construction. There is no fire blocking required in non-combustible construction. It doesn't exist in the code, because the whole point of it is fire propagates in hidden spaces that are made of wood or made of, with combustible things. So in Chandler's case, fire blocking is required in building 1 and building 3. It is not required in building 2 at all, because it's a non-combustible building. Fire stopping, I know that's similar terminologies, but fire stopping is intended to keep the fire and smoke from going through an assembly, i.e. getting into it, leaving it, or going all the way through it. And fire blocking is just inside the wall. So that's the critical thing to remember and they're not interchangeable. The terms are totally separate in the code, and there are different materials and systems used to take care of it. Technically, fire blocking is not the foam. The foam and the sealant and such that you see called as fire blocking, that's not actually the fire blocking. So, and I've already sort of gone through some of this of where it is. The fire blocking itself is the wood. So let's say you're doing a one-story residential home. You have to have fire blocking at where the ceiling meets the attic, at the top of the wall. Well, that's your double top plate. Your double top plate in wood construction is your fire blocking. If you have a wall that is more than 10 feet tall, let's say it's 12 feet tall, you also have to have a row of blocking at 10 feet or every 10 feet. It can be down at 8 feet even. But every 10 feet, you have to have a row of blocking horizontally all the way through that wall. So anybody that's done wood framing knows that if I have a wood frame wall and it's more than 10 feet tall, I got to do a line of blocking. Well, this is why. The point is to keep the fire from progressing all the way up the inside of that wall. And that 2x material is the blocking. And there's some other things you're allowed to use. You're allowed to use wood structural panels. You can use particle board, gypsum board, cement. I don't know what cement-based millboard is. And you can also even use bats and blankets of mineral wool, not to be confused with fiberglass insulation. Mineral wool is extremely different. It's much more dense, and it's much more fire resistive. If you've ever seen, and God forbid that anybody uses steel wool. Steel wool burns like it's actually fun to watch it burn. And insulation just melts. But mineral wool actually it'll burn eventually, but it's much more dense and much different. All of these are technically the fire blocking materials. What happens is you put holes in it. You have to maintain the integrity of the fire blocking. The code specifically says, and where it says here under integrity, that is the only line in the code that talks about sealing holes in, say, top plates, or sealing holes through the studs. If you're running MC cable from one side of the room to the other and you're drilling holes all the way through the studs, you have to maintain the integrity of that fire blocking at the top plate, through the studs, etc. This is the only sentence in the code that says it. The integrity must be maintained. Well, then how do you maintain, how do you maintain it? You have to use materials approved by the AHJ. It's really helpful. So what you find is there's a lot of different materials out there that talk about fire blocking, foams and sealants and such. The whole point of those is to maintain the integrity of that wood or that gypsum board, whatever was used for the fire blocking itself. Your sealants are not the blocking. Just keep that in mind. There are listed fire blocking sealants and foams. Almost every foam I've ever seen is only for use in residential construction, and they specifically exclude commercial. And I'll give several examples. Boy, you've seen this stuff, and they love advertising it at Home Depot, because you can get like 27 tubes worth. One can is equal to like 27 tubes of stuff. Like there's the 3M sealant. Well, if you look really closely at it, it says specifically is intended for use in residential applications. If you ask the manufacturer, it is not for use in commercial. This can be used in single-family homes. It cannot be used in any multifamily that's considered that falls under the building code. If it falls under the International Residential Code, you can use this stuff to maintain your fire blocking integrity. If you're in commercial construction, multifamily, you cannot use it. So for this entire Chandler Estates project, if it says for residential only, it cannot be used in this. We are a residential occupancy, yes, but we fall under the building code. We don't fall under the residential code. And that's the important thing to keep in mind. This great stuff is one example. Another one is the 3M fire blocking, or 3M fire block foam. And if you look at that real tiny type right there, it even says not to be used as a fire stop in commercial construction. It's on the can as well. It says not to be used in commercial. So it is only for single family or duplexes is what falls under the International Residential Code. All right, so what the heck are you going to use for fire blocking? Well, they do make fire block sealants that are actually for use in commercial construction. This one from 3M is an example. There's a whole bunch of manufacturers that do make them, and they are much cheaper than the one see on the right, which is the Hilti FS1 Max, which is a fire stopping sealant. Fire stopping sealants can be used to maintain your fire blocking. It's because if the AHJ approves, which I've never had one say no, because the fire sealants generally are more fire resistive than any of the fire blocking materials. But honestly, I wouldn't go through and use the most expensive fire sealant to do all your holes in the top plates when you can actually get away with using a less expensive fire blocking sealant. So, but when it comes to out there are very few foams that exist that should show up in a commercial building. For this reason, for fire blocking and fire stopping. Now, there's plenty of them for sealing around the windows and for sealing, for sealing the cracks for air infiltration, that kind of stuff. That's not what I'm referring to. I'm just referring to fire blocking and fire stopping. Okay, and so when I got the first few submittals, this is one of those big things that I wanted to bring up, is that I have yet to find a foam, and I'm sure they're out there. And if someone finds one that says, yeah, you can use it commercial on it, great. Then I want to see the cut sheet and go for it. Okay, so openings, maintaining. Now we talk about maintaining those fire resistive assemblies when it comes to keeping fire from going through them, getting into them, or getting out of them. That's where it comes when we come to through penetrations and membrane penetrations. So a through penetration is very straightforward. Any opening that passes all the way through the assembly. It goes from one side of the wall to the other. It goes from the, through it. Let's say you got a vent pipe that goes from inside the mechanical room through the ceiling and out the top of the roof. That's a through penetration. Membrane penetrations are like pretty much almost the majority of electrical and plumbing penetrations. It goes down through the top plate, out through one side of the wall. Well, now it was a penetration through the fire blocking, and it is a penetration through the membrane of the fire resistive assembly of the wall. So the port where it leaves the wall, i.e. you have your shut-off valves, your angle stops, I learned that term the other day, thanks Dustin, where you have those terminations for plumbing, that is a membrane penetration. And it does not matter whether it's above the ceiling or below the ceiling. If it goes through or goes into or leaves a wall, it is a penetration through the membrane. And it has to be fire stopped, the same as if it was a pipe going all the way through that wall. And it doesn't matter whether it's above or below the ceiling, because those barriers are even more important, below the ceiling. So fire stopping products have to be tested. They must be tested in accordance with a particular assembly, and they are tested for specific situations. I.e., you cannot. I don't care if a tube of and I hate the term caulk. Fire sealant. I don't care if the tube says 4 hours. If you don't have an assembly where it was tested in that exact kind of wall with that exact kind of penetration, i.e., what kind of pipe is it, what size is it, what's the material, what's it made out of, how big was the hole that it went through, all that information is actually in the assemblies that it was tested. And so you can't say, well, I got the sealant here and it says 4 hours so I can use it on the whole wall. No, absolutely not. You have to have the instructions for the exact condition that you are trying to protect. And so I'm going to get into that next here. It's that assembly. When I see people doing fire stopping on site, I expect that they have the assemblies with them, or they better know them pretty well. And they're not that complicated to understand. But it's basic 3 things that you have to know within an assembly. What are you penetrating? The assembly, the fire stopping assembly has to have been tested specifically for a wall, a roof ceiling. And then it has to say what type of wall. Is it gypsum? Is it metal studs? Is it wood studs? Is it gypsum board? What's the rating of it? How many layers of gypsum board are? How thick were those layers? It's all in that fire stopping assembly. Is it going through concrete? How thick's the concrete? You can't use an assembly designed for, say, 5.5 inches of concrete if you only have 2.5. If you only have 2.5 inches of concrete, the amount of assemblies that you have to choose from, there's a whole lot less of them. I actually, when I'm doing steel buildings with a composite steel deck and concrete slab, I on purpose prefer a 5.5 inch total thickness, because 4 inches is sort of that magical number for fire stopping assemblies. If you go below 4, I just cut the number of assemblies by half or less. I mean, it's absurd how few are there if you do a thin slab. If you do the thicker slab, it's like what we have in Chandler, where we have 8 inches of concrete. Whether it's 4 or whether it's 8, it's the same thing. And the assemblies are simpler. They're more numerous. So your choices are much bigger. And the ability to choose products and how you're going to protect it are much better when you have a thicker slab. So the assembly is incredibly important. You cannot use one fire stopping assembly in 2 different conditions. So the one for the wall doesn't work for the ceiling, or the one for the wall doesn't work for the concrete slab. Now, you might find assemblies that look similar, but they are 2 different assemblies, and I'm going to show you some. Second, the penetrant. We can make lots of jokes about this, but the material and the size of it is critical. What's it made of, and how big is it? If you're talking electrical, is it an EMT? Is it MC cable? Is it combustible cable? NM or Romex? Is it rigid conduit versus EMT? Are 2 different requirements, because it's a different thickness of material. One melts faster than the other. And then when it comes to combustible wiring, is what's referred to. So Romex or any low voltage wiring is combustible. Stuff burns and melts and just disappears in a fire. When you're talking 1,300, 3,000, it's gone. When it comes to piping for plumbing, is it metal What kind of metal is it? How big is it? Critical when you're doing non-combustible, or excuse me, combustible pipes, PVC, CPVC, PEX, all of those, that pipe is gone in a fire. So they have to be protected extremely much differently than you do a metal pipe. And so the requirements for in assemblies for combustible piping are very specific, and they I see them screwed up left and right. So you have to know the size of the material, and then you also have to know the size of the opening. You can't put a 1-inch PVC pipe through a 7-inch hole. It's too big. The fire stopping assembly says minimum size of the hole and a maximum size of the hole, and it refers to the annular space. The annular space is the amount of space between the edge of the hole and the thing going through it. So if you have a 3-inch hole and you have a 1-inch pipe, you basically have an inch of annular space all the way around it. And some assemblies allow you to have contact, which means, let's say the pipe can be right up against the side of the hole. Other assemblies, such as anything for PEX, it can't touch the side of the hole. It actually must have a minimum amount of space between the pipe and the side of the hole. And I'm going to show you some examples. Then the last thing is the fill material. And the fill material could include mineral wool. And a lot of time mineral wool gets used as more as like a backer rod. You have to have something to keep all the fire, all the sealant from just filling the hole. So some assemblies require mineral wool, some don't. But then they all have some sort of fire stopping system or product. It could be just a fire stopping sealant. It could be some kind of putty. It could be a collar system, a metal collar system that wraps around the pipe and attaches to the wall. They make specialty collars that go all the way through the wall, and that you can twist and untwist and pull cables through and then twist it and close it up again. All of those systems have a fire stopping material in them that either keeps the fire, it stays in place and the fire can't get past it, or it actually expands, which is the term is used as intumescent. If you have an intumescent material, it expands. Every assembly that protects combustible piping and wiring uses an intumescent material because the pipe's gone and you have to fill the hole. So now I'll show you here. This is, and that's really small. You really can't see it. But every fire stopping system, this is what they basically look like. And this is all the cover your ass jargon here at the top. And then it'll describe what the rating is. And the rating has to match the wall. So if it says 1 hour or 2 hour, if you're using this assembly to protect a penetration through a 1 hour wall, it's a 1 hour rated fire stopping assembly. Like I said, the sealant could say 4 hours on the tube, doesn't matter. It only matches what the wall is. So the first thing is that this one, it's the wall assembly. What's it going through? And it describes, in this case, and I can't even read it myself, like wall framing may consist either of wood studs or channels. Wood studs to be spaced, wood studs should be 2x4, spaced, So it tells you exactly how the wall is built. Sometimes it's very generic like this. Other times it will refer to very specific tested assemblies, like UL design U434. That means that it was only tested for that wall, that exact type of wall. So if you don't have that type of wall, you can't use this assembly to protect that penetration. Then it also talks about everything in the wall. So it talks about the chipboard. It talks about how thick the chipboard is, how many layers of it, etc. This basically is a copy or a summary of the assembly for the wall that it was built to. Excuse me. Then it'll tell you, number 2, what's going through the wall. In this case, it's electric metallic tubing. It's EMT. So here it says 1 or more 1-inch diameter. I think that's 1-inch diameter maximum with an annular space shall be a minimum of 1/2 of an inch. So in this case, this particular assembly, you can actually put EMT through a big, long, rectangular channel. But the minimum space between the edge of the EMT and the edge of the hole is 1/2 inch. And that's in this area right here. And then it says to a maximum of 1 inch. That's not a whole lot of room to play. So if you've got a 1-inch EMT, that the minimum size for that channel is 2 inches. 1 inch plus 1/2 and 1/2. but the maximum is 3 because you can have an inch of EMT, an inch on top, and an inch on bottom. But so if you do a 4-inch, if you do a big 4-inch, a rectangle, you're repairing the board first. You can't use this assembly to protect a hole that's 4 inches with a 1-inch EMT going through it. There's a lot of different assemblies. In fact, I almost guarantee you there's an assembly for almost every situation. And if Hilti hasn't already tested it, they probably will. Actually, I know for a fact they will because I brought them several and said, hey, STI has this, you don't. And suddenly the next week they had one tested. And then the last one here, it tells you what the fill material is. So in this case, it says Hilti FS1 sealant. And the FS1 sealant is it's the red stuff you're used to. And if anybody who's put in Firestopping knows how nasty that crap is to get on your hands. And but it's an intumescent. It'll expand, so it'll fill in around all these conduits. Even more so important, like I said, if it has a combustible piping. So this is the assembly that I would expect, that I do expect, anybody who is installing Firestopping should know what assemblies they're using, because you're only going to use so many for your trade. If you're doing plumbing, you're only going to have so many types of pipe, and they're only going to be going through so many different types of walls. So there's only so many assemblies that you're going to be using. Now, once you know the requirements for them, you don't have to carry the sheet with you. That's stupid. But until you know the requirements for them, I would expect that have someone having this in their back pocket, or at least knows it really well. And what we're going to do actually for Chandler, and this is a side note from this presentation, is we're going to do a mock-up. And so and this is required in the construction documents and the specifications, to do a mock-up. And so each trade needs to have one example of every single of their penetrations, i.e., if it's for electricians, I want to see the EMT, the MC. If there's Romex in building 3, I want to see a Romex penetration, all of them in this mock-up and fire stopped exactly per the assembly. And then that is exactly what we're going to gauge every single fire stopping, every hole that's created by that kind of penetration. We're going to gauge it against that mock-up. Fire stopping can be messy, but it can also be done cleanly. I'm going to skip through some of these fast because I'm already about way over time, I know. There's so many different things that are penetrations. It's ducts, it's piping, it's wiring, it's HVAC ductwork, obviously. There's a lot more things that people don't think about. Electrical, these are all things that get recessed into walls, some of which are not rated and can't be. There's no such thing as a rated electrical panel. Doesn't exist. I have never found one that actually is classified for installation in to be recessed into a rated wall. They actually, they don't exist. Now, 4x4 electrical boxes, absolutely, but there are specific requirements for those. Sink drains, cleanouts. You don't think about that one, but cleanouts, it pops through the wall. Where that cleanout pops through that wall, and if that wall is a barrier, that hole has to be fire stopped. And there are specific ones that include the cover and everything. Obviously, electrical boxes and such is a huge one. They metallic electrical boxes are classified by UL automatically. They have one big listing for all of them, but they must be installed per that listing, which says the gap around that metal box can't be bigger than 1/8 of an inch. If it's bigger than 1/8 of an inch, it no longer meets this listing, and now you have to protect it in a different way. That's a putty pad. The reason you use putty pads is if it doesn't meet this listing, i.e. the hole's cut too big, then you use a putty pad. There's also requirements, this is another discussion, about spacing on them. And I have actually a document that explains that kind of stuff really well. There's also a lot of issue with recessed lights. We don't have this issue in Chandler, but if you do a lot of stuff that has recessed lights, and especially on electrical, there are very specific requirements for it. These are terrible examples of what not to do. These are older pictures. We don't even use some of the stuff anymore because now we use the LED lights. But it's important to really know the listings. Don't read cut sheets. Cut sheets lie to you. They're made by marketing people, and I have literally found them where it's fire rated. No, it's not. Never been tested. It's not listed. I've actually had those. Dampers, incredibly important that the dampers are not only listed and specified for where they're supposed to be, they must be installed per their instructions. I haven't actually seen a damper instruction manual that required fire stopping around the damper. In fact, almost always you do not want to put fire stopping around a fire damper collar. There are inspectors that will require it. So when they do, that you need to use the right kind of fire stopping. You need to use fire stopping that does not expand, because you'll know that obviously as it expands, it's going to contract the duct, and that damper is not going to move. So that's its own thing that I'll be happy to talk with American about. There's amazing the number of things you don't think about. The penetrator wall, recessed toilet paper, holders, stuff like that. All of that is a penetrant, and it all has to be protected either by a fire stopping system or by other means of wrapping things in gypboard. By the way, gluing gypboard together is never a radiated assembly. So if you have like a fire extinguisher cabinet, you can't do 2 pieces of gypboard on the back side and call it 1 hour. It doesn't exist. Interestingly enough, every rated fire extinguisher cabinet is actually a component of a fire stopping system. It is tested like fire stopping. This is just an example of how they actually test fire stopping. So this is the furnace on the other side. Everything there is done exactly per their assemblies, and then they are tested for the time. And then here's an example of a combustible pipe. This is a collar that's used on those. One of these is on the fire side. The other one is on the non-fire side. And so you can see why it's so important that you maintain both of them. One of them is going to fail fast. On the fire stopping on one side of the wall will fail faster than the other. But they will both fail, especially when they have a large pipe going through them like this. There's a lot of penetrations you don't think about, especially in plumbing. All the sink drains down below, all the toilet supply lines, shower supplies. That brass valve going through a rated, if it is a rated wall, that's a problem because it needs to be fire stopped because it's a hole. Clean out covers, etc. And there are assemblies to protect these. So I wanted to show you some examples of some terrible fire stopping, and then also some examples of some good ones. And I go through these pretty quick. Obviously, the one on the left is pretty straightforward. It's not fire stopped. That's actually above a freezer cooler. And so they didn't think about it because you can't see it from the ceiling. The one on the right, those are a whole bunch of fire stopping collars for these large PVC Schedule 40 conduits. But somebody literally pulled them from the other side and ripped them right through the wall. So they don't do a whole lot of good. And here's an example of a same kind of thing, PVC, and it's got a collar on it, but you can see the pipe above the collar. So the spalling in the concrete made the hole so big, the collar is worthless. The one on the left is actually somebody put in, I think that was plaster, into a concrete wall for the conduits. Collars are done wrong so often. I hate rules of thumb, but if you have a combustible pipe greater than 2 inches, it is going to require a collar or a wrap strip of some sort as part of its assembly. Sealant on its own can't do anything bigger than 2 inches when it's combustible. Steel pipe and such, that's a different discussion. So these right here, you can see they're probably line sets or they're just insulated pipes, but the collars are terribly installed and they have FS1 all over them, that's sealant. Most of these collar assemblies do not require any additional sealant because inside that collar is a fire stopping material. It will expand on its own and fill the hole. They're not needed to have all this other sealant. Messy things like this are actually, it's worse to put more fire stopping on something than to do it right. Here's another example. You cannot mix penetrations unless the assembly says you can mix penetrants. You can't put wiring through the same hole as a pipe unless it says you can, and most of them don't. This is a good example. They put multiple pipes through a collar around it, and the collar's nailed into the wall. Every fire stopping assembly uses a collar. They're required to be screwed, and so many screws per the size, etc. There's so many things wrong about that one. I don't really have to explain this one, but not only it's missing, it needs a collar for that one, for the big white PVC pipe there, but there's yellow foam used for sealing around. That's great stuff. Foam is only for use for air resistance. That's it. But this is such a disaster and a mess, and it's not fire stopped even a third of what needs to be there. But it's such a disaster you can't even see if it's done correctly. This one, there's huge pipes going through the wall. They're way bigger than 2-inch. They all have to have some sort of a collar or a wrap strip on them. This one is actually really clean looking, and I was actually rather impressed. But I hate collars. I'm not a fan of them. A lot of assemblies that use collars say you can use a collar or it's optional to use them. The problem is with combustible wiring, and that includes MC cable, because MC cable is usually aluminum, they are only allowed to fill 45% of the hole they go through, or 45% of the sleeve, or that the conduit like this, in the case they were using these as a sleeve. So those things are full almost 100%. I mean, they're probably like 90%. Every single one of those has to be removed because the holes are too small for the amount of MC cable going through them. So they did a great job of fire stopping the sleeve at the ceiling, but the sleeves are too small for the amount of stuff going through them. They're also not fire stopped. There's no fire stopping sealant in the sleeve where the MC goes through it. So fire and smoke can go right up that conduit. And if they did put fire sealant in there, you couldn't get enough in there because to actually seal up that conduit or that sleeve when all that MC cable burns or melts. So all of these had to be totally redone because they did not meet the assembly, even though it looks nice and clean. That's pretty straightforward. By the way, every rated assembly has to be taped and floated, and all screw holes or nails must be covered for the outer layer. If it's a 2-layer assembly, you usually can do the first layer. This is per the assembly itself, but usually says you don't have to tape and float the first layer, but you have to tape and float the second layer, level 1, and all the nails and screw heads must be covered. So there's all sorts of stuff wrong about this one. A good example of, they did a great job with the sealant, but that pipe is bigger than 2 inches. So it's got to have a collar. And then the duct actually to the right, that is a steel duct. It's not flexed. So that actually is correct. They actually did use the right amount of sealant. And there is an annular space around that duct. This is one that did not need a damper in it. They're nice collar they use, and those collars are going to be expensive. You can't mix all those pipes together. You can't mix all those conduits. And that one's pretty self-explanatory. Here's some good ones. This is where a beam meets a wall. And the fire stopping sealant is extremely well applied. Fire stopping sealants are not all red, and there's no standard for their color. So if you choose, if there is something that we allow that is not red, documentation is so critical. There's also a very clean, going through like a smoke barrier in a healthcare facility, very clean. These are actually 2 mock-ups that are these are upstairs in my office at home. I made these on my truck bed at 10 o'clock at night under a street lamp at a hotel before doing a presentation. These are examples of various assemblies, and there's actually a wood framing behind it and a steel frame that I did, and I did them exactly per the assembly so I could show people. So the mock-ups that will be on site, they're going to be larger than these, but that's the idea, is that it's going to show the different kinds of penetrants, how we're going to protect them, and then we also, next to each one, we're going to list what is that assembly. Hilti actually makes stickers, and you'll see when I zoom in here, Hilti makes stickers that you can actually use to mark all the assemblies. I love them. They're not required by code. They're in our specifications, but I've never been too hard about making us do it. They're not expensive, but they're a great idea because it shows you the material that was used. It shows you the assembly, in this case, WL2186. That's the assembly. That's the system. And then it's got the date and who put it in, and what the penetration is. So it's a little bit of accountability to actually do these, and that's why I love them. Now this is actually PEX. This is a good example. This assembly requires that it be almost centered in the hole. PEX can't go up against the edge of the hole. Here's a good one for MC cable. MC cable can touch the side of the hole. If it does, then you do a fillet, and it looks sort of like a fillet weld. You do a bead of sealant, and it's usually a 1/4 inch or a 1/2 inch, whatever the assembly says. And then you would do that around the edge. Where it has the space or that annular space, the fire stopping sealant should be flush with the gypboard. I shouldn't see mounds of fire sealant. It's not necessary because it actually needs to be 5/8 of an inch thick in the hole, and that's what the requirement is. And then if I say it's up against the edge, then I should see just that small bead of sealant. A lot of sealant is wasted by people throwing a whole bunch on there, and it's usually done wrong. So there's multiple conditions obviously, and it's real easy to do these on the back of a truck bed at night, and it's another thing doing them in attic. Trust me, I do. I fully get that. Here's a good example of a PVC pipe. This is a 1-inch pipe, so it can be used without having to use a collar, but it does require a certain amount of annular space. And then here's one with Romex going through it, and there you can see how it only fills a certain percentage of the hole. And then I bring this one up there again for that 1/8 of an inch. They have to be cut tight in order to maintain their rating. If they're not cut tight, they have to have a putty pack on them. I always love this one here because it's a smoke barrier wall. It's actually a 1-hour rated one, but she talks about being airtight, and then right above it to the right, the cable that goes up there is anything but done correctly. I've actually seen these signs where they actually have the cables and such going right through the sign and not fire stopped. So so I want to open up the microphone. Anybody has any questions? I have a bunch of other materials here pulled up that I can show you too. I probably have to stop sharing or no, I do. Can you open up a mic or anything like that, Dustin?
I'm open on our end. I got you off mute.
All right. Anybody have any questions?
Yeah, I have a question on the boxes.
Yeah.
So for the electrical boxes, the 4 squares, 411, you're saying that if they're cut tight within 1/8 of an inch, that we won't need a putty pad?
Under certain circumstances. So let me end my. How the heck do I get out of this thing? Hang on a second. I'm going to try to. There we go. Okay. Let me show you. So I actually have I have a set of details that I use, and they're actually in our drawings. If you go to the G series sheets, there are details that are exactly these, and they tell you exactly what the requirements are for spacing of boxes and when putty pads will be required. So one reason to have a putty pad is if you don't cut it tight. So that's a given. If you don't cut it to within 1/8 of an inch, you have to use a wall opening protective material, which is a putty pack. Now they used to have just putty packs on the outside. Now they have those inserts that you can put on the inside of the 4x4 box when they get cut. Because how the heck are you going to put a putty pack on it when the gypboard is already on the wall? But they do make inserts now. I highly suggest. That's why I like the 4x4 metallic boxes, because there are way more inserts for those than there are for any non-metallic box. So that's what the basic installation guidelines under UL's listing talks about, how many you can have within a wall. So you can, they can't exceed 16 square inches, 4x4. And so you can't do a 4x8 box. If you have and I tell you all the time, the night lights in nursing homes, the older ones, the incandescent lights, were like 4x8 because it's a housing. That is not a 4x4 electrical box, and unless that housing is actually tested for fire resistive, and it's actually listed correctly, it can't be used in a wall. But 4x4 boxes, and then you can't exceed 100 square inches per 100 square feet of wall. If you exceed it, they have to have putty packs on them, or the inserts. So those are two reasons that you'd have to have it. The next reason is the spacing, and this one is so misinterpreted all the time. Metallic outlet boxes on opposite sides of a wall must be separated by 24 inches horizontally. It doesn't matter how far apart they are vertically, and it doesn't matter where the studs are. Forget the term stud cavity when it comes to outlet boxes. It doesn't exist in the code, and I've had fire marshals literally tell me, oh well, they're in different stud cavities. That does not exist in the code. It does not exist in the listing. The listing says if they're within 24 inches horizontally on opposite sides of the wall, they have to have putty packs. If they're 26 inches apart, they don't. If they're 23 inches apart, they do. So I have some examples. Like here's 3 right here on example A. All 3 are on the same side of the wall, and let's say they do not exceed the 100 square inches per 100 wall. They do not require putty packs. And they were cut within 1/8 of an inch. You know, they're done right. I don't care if it's a smoke barrier, a firewall, or fire barrier. It doesn't matter. If they're cut tight and they're all on the same side of the wall and they don't exceed the area, they do not need putty pads. But if you have, or like here's the second example. These are 26 inches apart on opposite sides of the wall. They do not require putty pads because they are at least 24 apart. Now the next one, you've got 3 boxes. 2 of them are close to each other on opposite sides of the wall. So the 2 boxes on the left need putty pads because they're only 10.5 inches apart. But the box on the left and the far box on the right are more than 24 apart. So the one on the right doesn't need a putty pad because it is more than 24 inches from any box on the other side of the wall. All you care about is boxes that are on the other side of the wall. That's the critical thing. And keep in mind, it has nothing to do with stud cavity. These boxes could be 10 feet apart vertically. The rule still counts. Doesn't matter how far apart they are vertically, only how far apart they are horizontally. So this is actually, these details are actually in the drawings. And they're in the G sheets. In fact, I can probably just pull them up, and I want to say it's under G901. There they are, right there. Detail number 9 on G901 has those drawings and the requirements right there. I got tired of explaining it, so I put it in the drawings.
Yeah, now add that, I would suggest everybody takes a look at these G sheets and drawings, and also there's some great information in the specifications manual under the fire stopping section.
Yeah, and these G series are specifically the G series. You know, there are G series drawings in every architect's set because that's where you put your life safety plans. That's the stuff. I specifically started doing the G series to that's not the one, to better explain fire resistive construction, because there are so many things that are done wrong so often that I really wanted to. I got copied over, but there's actually one in there that explains fire resistive construction. Yeah, I think it's supposed to be G100. Take a look at those because there's a reason I actually put those sheets in there. I'm not a fan of putting sheets in there that don't, that fill space. So, good question.
I got a question, Sean. Is it still legal to a firewall penetration if you have a steel pipe that goes through, extends 4 feet of both sides of that firewall, and then you run your the wire piping through it, and then fire caulk the ends? Still acceptable penetration?
No, as long as that sleeve is fire stopped where it goes through the wall. Yeah, there's no requirement for actually the length on the sleeve. The sleeve can be, the sleeve can end right at the face of the wall. It doesn't really, it doesn't say I haven't seen an assembly that really specifies the length of it, because it doesn't, unlike rated windows and rated doors within certain distance of a firewall, the fire stopping is treated like any other wall. So there's no difference whether it's a firewall or a fire barrier on how long the sleeve is, whatever. The fire stopping is still the same assembly. Now, but you do have to have one that works for that firewall. You'll see a lot of firewalls that are, use those 1-inch gypsum panels and with the metal clips on both sides. And you have to use an assembly that works with a 1-inch gypsum panel, not a 2x4, wall with gypboard both sides, because that's a very different assembly. And there's a lot less assemblies for shaft wall assemblies, fire stopping assemblies for shaft wall. Okay. Who else got a question? I'm surprised that you didn't ask me about, do you have to do a duct penetration through the mock-up? No, I don't think it'd be necessary. No, unless you just want to grab a little small 6-inch duct, that would be actually good to do it as a mock-up.
Yeah, T, we'll get together and start that mock-up here over this week or next.
And I actually have, I actually will send you some drawings of it. This is actually, oh, doesn't want to share that very well. This is actually in SketchUp. This is actually the, this is an idea of what that mock-up could actually look like. So you do one that's wood, one that's metal, because they're going to be different assemblies. And then you have head of wall assemblies, and you have the bottom of the wall. So you're going to need one that shows how the walls hit the deck and how that's fire stopped. You could need one that shows how it hits the concrete. So you could use a piece of wood that's on the top of maybe the other one to show how the wall would, fire stop, or how the joint fire stopping would be at the head of the wall. And then these you could do studs like every 12 inches or something on the back side to give you plenty of room to, or plenty of spots to attach the pipes and other penetrants.
Okay.
That's an idea. It's an idea of because it is to do all of the different penetrations you're going to have. You'll probably need a good 4x4 or so.
I didn't hear, but does the mineral wool have to fill the whole sleeve completely from end to end?
So most of the assemblies that use mineral wool, it just says, it usually calls out to have mineral wool behind it. It doesn't call out a specific thickness. That's a good question. Let me look. Actually, I have some assemblies that are actually taken from our drawings.
So we have, if we were to have a 4-inch sleeve with 10 pieces of MC in it.
So if,
You still have to keep your 5/8 of fire.
Yeah, so you'd have exactly,
The
you'd have 5/8 of an inch on either end. So right there, you're at 1 1/4 inches. And then, well, here's a good example. That's a non-combustible pipe. I'm looking for a sealant. Oh, here we go. Well, this one's for combustible cables, but the MC is going to be very similar. See if I can pull it over and actually see it. So here's one for combustible cables, which is actually all the low voltage, coaxial, etc. But I know that the ones for MC are going to be very similar. Actually, this one's MC here. But this one shows a sleeve. So in this case, it actually says metallic sleeve. It shows the cables, and then it just says the sealant. This one does. You may use packing material. It says mineral wool forming material may be used as a backer for the fill. The fill material being the actual sealant. It's like backer rod. It's only there to keep it from falling through the hole while you're installing it. It's very, very seldom is there actually a required thickness of mineral wool. So for example, in this one, there's no in fact, you don't even have to use it. I'd probably recommend it because otherwise you're going to spend a lot of money on fire stopping because you're going to be filling that hole. Because if you can only put 45% of that sleeve full, then you got 55% of that sleeve that's going to have a big hole behind it.
So there's no covering that I guess you would call it, well, the space of the sleeve with the putty pad.
No, you would not use a putty pad because unless it specifies to use some. So there are FS1 is one example. That's the kind that comes in the tube. I don't know if you can see me on camera or not, but this is there's just your standard FS1 tube. I still have these left from when I made the mock-ups. They're expensive. I'm not getting rid of them. But there are also assemblies, and I took a picture of one, and I think I forgot to put it on my computer, of ones with wrap strips. So it's actually the stuff that's inside the collar, which is it's a strip of intumescent material. I actually did them on here in when we built our office, which is a 7,000 square foot multi-use building, and I did all the fire stopping for the 4-inch Schedule 40 conduits coming in for the electrical, and I did all the fire stopping on them. And the collars were expensive, so I found an assembly that used a wrap strip. And so there's 2 layers of wrap strip that are shoved in the hole, and then it's all has the FS1 on top of those. And it was cheaper than buying the collars for each individual one. But there was no mineral wool in that one. Now, in like these concrete ones, here's a good example. This one is also cables again. You can see there's the thickness of the concrete. The FS1 is on the top side. It's 5/8 of an inch thick. Or actually, this one probably says, no, actually, this only requires 1/4 of an inch thick FS1 sealant. Here, it does say minimum 4 1/4 inch thick of mineral wool. So in going through the concrete, this particular one has an optional sleeve, but it does require mineral wool filling up that whole space. So the wall ones don't usually have that. The ones going through the concrete very often do. Your vertical ones.
And just fire cloth on top.
Yeah, it's this one here actually. So item number 5 is the sealant, and the sealant says it's a minimum 1/4 inch thickness of fill material applied within the annulus, flush with the surface of the floor. This also works for a concrete wall as well. So if you do it correctly, you put in the cheaper mineral wool, and it only needs 1/4 inch thick of FS1 that seals it. This is why I love thick concrete, because this assembly only works if the concrete is a minimum 4 1/2 inches thick. If it's a 2-inch thick concrete, you don't get to use this one. So that's why I like the thicker slabs. And we have 8 inches of concrete at Chandler, so there's no issue with concrete being too thin. But like, here's one for a standard metal pipe, and it can go. This one can go all the way up to 30 inches in diameter for steel, 6 inches for copper, and for where it says conduit, i.e. rigid conduit, you can go up to 4 inches, and it just has the sealant. That's it. Just has the sealant 5/8 of an inch thick, or a 1/2 inch bead, 1/2 inch diameter bead if it touches the edge of the hole, which matches like the ones that I had in the mock-up that I did. This is going to be a very common one for for fire sprinkler if you have steel pipe, or any of your steel pipe. I did not mention in this, and it's critical. I don't think our fire sprinkler guys are there. CPVC is not compatible with a lot of fire sealants. A lot of them. In fact, the ones you get at Home Depot, those 3M ones, are not compatible with CPVC. The 25W plus, they specifically says do not use with PVC. UL even has this whole white paper out talking about the compatibility. There's something chemically reactive between the CPVC and a lot of the fire stopping sealants. Now there are fire stopping sealants that are FS1 is actually compatible with it. And of course, the more expensive one is compatible. That's part of the way that's supposed to work. Good questions. Any others? I'm sure I'll have plenty to answer when I'm out there too. But I'm hoping everybody learned something today, something they didn't know, and or maybe you didn't, you fell asleep. I can fully understand that. This is not exactly super exciting material, but it is critical. Like I said, the tiniest of hole that is not done properly can be the failure in a wall, and can literally mean a life on the other side of that wall. And it is that important. A fire doesn't even have to be on the side of the wall for the smoke. Like I said, the people that died in the MGM fire were 16 to 26, so they were 14 stories above the fire, and that's where the majority of the people died. So it's fire stopping and fire blocking are critical to making sure this building keeps the people that are in it safe. And this, although it's not in a licensed, assisted living or something, this independent living has people that are over 55 and much older, and are slower to move out, and they need that protection. And so it's everybody that works on this job's responsibility to make sure that they are protected. So. You can tell I'm passionate about this one.
We appreciate it, Sean. It's a great presentation, great information. That's really well done.